Hello, future listeners, subscribers, viewers, and students. There is another method of computing the slopes and deflections at various points in a beam, and this is by Castigliano's second theorem. This is the original problem. The beam is subjected to the loads shown. If EI is constant, determine the slopes and deflections at points A, B, C, D, and E by the Castigliano's second theorem. So first, we compute the slope at A. So we apply a couple C sub n at A and solve for the reactions due to that couple. So the original reactions in the beam at A and B were 107 over 3 kilonewtons and 353 over 6 kilonewtons. So if we just focus on the contribution of C sub m, summation moment above D equals 0, so reaction at A due to C sub n times 9 equals C sub n. So that's why this is now 107 plus 3 plus C sub n over 9. And at the right side, 353 over 6 minus C sub m over 9. So same sectioning, 1, 2, 3, and 4. So EI times quantity 1 times theta, this is the formula, summation of integral 0 to L of moment, then the derivative of that moment with respect to the couple C sub n dx. Then for deflection, EI times 1 times deflection equals summation integral 0 to L, moment at a segment in a beam, then times the partial derivative of that moment with respect to the applied load P, which is positive upward, times dx. So for slope at A, so the moment at this section is quantity integral of quantity 107 over 3 plus C sub m over 9 times x. Then the derivative of this moment equation with respect to C sub m is x over 9, then minus 1. The moment at this section is 107 over 3 plus C sub m over 9 times x minus C sub n. So the derivative, partial derivative of that moment equation with respect to C sub n is x over 9 minus 1 dx. Setting the value of C sub n to 0 prior to integration, limit 0 to 3, so you'll get negative 749 over 6. Then for section 2, the moment is negative 15x, but the derivative is 0, so the integral is 0. Then for section 3, moment is integral 0 to 3 of moment quantity 353 over 6 minus C sub m over 9 times x, then minus 15 times quantity 2 plus x, then the derivative, partial derivative of this moment equation with respect to C sub m is negative x over 9 dx. Then the integral is negative 173 over 6. So of course, setting C sub n to 0 prior to integration. Then lastly, for section 4, we have integral from 0 to 3 of 353 over 6 minus C sub m over 9 times quantity 3 plus x, then minus 15 times quantity 5 plus x, minus 12 times x, minus 15x times x over 2, or 7.5x squared, minus 1/2 of W4 times x W4 moment arm x over 3. This is 5x cubed over 6. Then the derivative, partial derivative of this moment equation with respect to C sub n is negative 3 plus x over 9. Negative 3 plus x over 9. So integrating, it is negative 547 over 3. So combining values, negative 547 over 3 minus 173 over 6 minus 749 over 6 is negative 336 over EI, just like in the previous calculations. Next, for slope at B, so we apply C sub m counterclockwise at B. Compute for the reactions again. So due to C sub n, this is 107 over 3 original due to loads plus C sub m over 9 because AY times 9 equals C sub m. So that's why we have plus C sub m over 9. The right support reaction at D is 353 over 6 minus C sub m over 9. So same sectioning. EI 1 times theta B equals integral at this section. Quantity integral from 0 to 3 of 107 over 3 plus C sub m over 9 times x. And the derivative is x over 9 dx. So setting C sub m 0 prior to integration. And the value of the integral is 107 over 3. Then in the next section, it is negative 15x times 0 because the moment equation is not function of C sub m. So the second integral is 0. The third integral moment at this section is quantity integral 0 to 3. 353 over 6 minus C sub m over 9 times x and minus 15 times quantity 2 plus x, the partial derivative of this equation with respect to C sub m is negative x over 9 and dx. Setting C sub m 0, then integrating 0 to 3, the answer is negative 173 over 6. Then for the last section 4, integral of quantity 353 over 6 minus C sub m over 9 times moment arm 3 plus x, then minus 15 times quantity 5 plus x, minus 12x minus, we just copy the previous moment equation, 12x minus 7.5x squared minus 5x cubed over 6, the partial derivative of this moment equation with respect to x, with respect to C sub n is negative 3 plus x over 9x. Then setting C sub m 0 prior to integration, I'm using your high-tech calculator. The integral is negative 547 over 3 combined with negative 173 over 6 and 107 over 3. Then we have theta b equals negative 175.5 over EI, just like before. Then for deflection at B, we apply an upward load P at B, then add the effect of this P here, upward load, so it is downward. Then we have the reaction at A, vertical reaction at A is now 107 over 3 minus 2P over 3, while at B is 353 over 6 minus P over 3. So EI, deflection, EI times 1 times deflection at B is equal to integral from 0 to 3 of quantity 107 over 3 minus 2P over 3 times x. The derivative with respect to P is negative 2/3 x dx. The integral in the second section is 0. Then in the third section, the integral 0 to 3 of quantity 353 over 6 minus P over 3 times x. Then minus 15 times 2 plus x. The derivative is negative x over 3 dx. Then for the last section, integral of 0 to 3 of quantity 353 over 6 minus P over 3 times 3 plus x. This is it. Then minus 15 times 5 plus x minus 12x minus 7.5x squared minus 5x cubed over 6. The derivative with respect to P is negative 3 plus x over 3 dx. So setting P 0 prior to integration, the integral of first is negative 214. The second is negative 173 over 2. Second 0, by the way. Third section, negative 173 over 2. And in the fourth section, negative 547 combining negative 547 minus 173 over 2 minus 214, the result is delta P negative 847.5 over EI. So next, for theta C, we apply a couple C sub n counterclockwise at C, then solve again the reactions at A due to that couple alone. So reaction at A times 9 equals C sub m. So this is again 107 over 3 plus C sub m over 9, and here 353 over 6 minus C sub m over 9. So EI times quantity 1 times theta C equals integral in this section 1 here of 0 to 3 of quantity 107 over 3 plus C sub m over 9 times x, the derivative of this moment equation with respect to C sub m is x over 9, and dx, setting C sub m 0 and integrating, the answer is 107 over 3. Then at section 2, integral is 0. At section 3, we have integral from 0 to 3 of quantity 353 over 6 minus C sub m over 9 times x, then minus 15 times quantity 2 plus x. The derivative with respect to C sub m is negative x over 9 dx, setting C sub m 0. Then integrating, we have negative 173 over 6. Then in the last section, fourth section, we have integral 0 to 3 of quantity 353 over 6 minus C sub m over 9. The moment arm is 3 plus x, then plus C sub m minus 15 times quantity 5 plus x minus 12 times x minus 7.5 x squared minus 5x cubed over 6. The derivative of this moment equation with respect to C sub m is 1 minus 3 plus x over 9. And setting C sub m 0 prior to integration, the value of the integral is 4345 over 24. So adding 4345 over 24 minus 173 over 6 plus 107 over 3, we'll get theta C 187.875 over EI. Next, we apply a load P upward at C, then solve for the reactions. Focus just on the contribution of P. So we have here reaction downward times 9 equals P times 3. So that's why this is 107 over 3 minus P over 3. Then downward reaction at B times 9 equals P times 6. So that's why at D, the reaction is 353 over 6 minus 2/3 P. So EI times delta C, 1 times delta C, equals integral from 0 to 3 of quantity 107 over 3 minus P over 3 times x, and the derivative is with respect to P is negative x over 3 dx, setting P 0, then integrating, we have negative 107. The integral at section 2 is again 0. The integral at section 3 is integral 0 to 3 of quantity 353 over 6 minus 2/3 P times x minus 15 times 2 plus x. Then the derivative of this equation with respect to P is negative 2/3 x, setting P equals 0, integrating, it is negative 173. Then at section 4, we have integral 0 to 3 of quantity 353 over 6 minus 2/3 P times 3 plus x, then plus P times x, then minus 15 quantity 5 plus x, minus 12x minus 7.5 x squared, minus 5/3 x, 6x cubed. Then the derivative of this moment equation with respect to P is x, dx of x, then minus 2/3 of 3 plus x dx. Integrating and setting P 0 prior to integration, the value of the integral is negative 4045 over 8. Then combining with negative 173 and negative 107, the deflection at C is negative 823.125 over EI. Next, we apply a couple at D, C sub n to solve for theta D. The reactions at A would be 107 over 3 plus C sub m over 9. At D, 353 over 6 minus C sub m over 9. Then EI times 1 times theta D, integral 0 to 3. Moment at this section is quantity 107 over 3 plus C sub m over 9 times x. Derivative with respect to C sub m is x over 9. Dx, setting C sub m 0 and integrating, it is 107 over 3. At section 2, it is still 0. At section 3, we have integral 0 to 3 of quantity 353 over 6 minus C sub m over 9 times x, then plus C sub m, then minus 15 times 2 plus x. The derivative of this moment equation with respect to C sub m is 1 minus x over 9 dx, setting C sub m 0 prior to integration and integrating, it is 941 over 12. Then at section 4, the integral, we have integral 0 to 3 of quantity C 353 over 6 minus C sub m over 9 times 3 plus x, then plus C sub n minus 15 times 5 plus x minus 12x minus 7.5x squared minus 5 over 6x cubed. The derivative of this moment equation with respect to C sub n is 1 minus 3 plus x over 9. And dx, setting C sub n 0 prior to integration and evaluating the integral, it is 4345 over 24. Combining with 941 over 12 and 107 over 3, theta d is 295.125. So for the slope at E, we apply a unit couple C sub m counterclockwise at E. So computing for the reactions due to the C sub m only, we have 107 over 3 plus C sub m over 9 here. Then here, 353 over 6 minus C sub m over 9. Just focus on C sub m only. Then, we have EI times 1 times theta E equals integral of quantity 107 over 3 plus C sub m over 9 times x. The derivative with respect to C sub n is x over 9 dx. Then setting C sub n 0, integrating, it is 107 over 3. For section 2, it is integral of quantity C sub m minus 15 times x. Then the derivative of C sub m minus 15x with respect to C sub n is 1 dx. Setting C sub m 0 and integrating, it is negative 30. At section 3, we have integral 0 to 3 of quantity 353 over 6 minus C sub m over 9 times x, then plus C sub m minus 15 times 2 plus x, then the derivative with respect to C sub m is 1 minus x over 9 dx, setting C sub m 0, then evaluating the integral, it is 941 over 12. Then the last section, section 4, we have integral of from 0 to 3 of quantity 353 over 6 minus C sub m over 9 times moment arm 3 plus x, then plus C sub n minus 15 times 5 plus x minus 12x minus 7.5x squared minus 56x cubed. The derivative of this moment equation with respect to C sub n is 1 minus 3 plus x over 9, then times differential x. Setting C sub m 0 and evaluating the integral, it is 4345 over 24. Combined with 941 over 12, negative 30, and 107 over 3, we'll get 265, theta E 265.125 over EI. Then, finally, for the deflection at E, upward load P at E, then compute for the reaction. Reaction AY times 9 equals P times 2. So that's why this is now become 107 over 3 plus 2/3 of P. Then reaction at D, times 9 plus p times 11 equals 0. So it is negative 11 p over 9 for reaction at B. So integrating EI times 1 times delta E equals integral of quantity 107 over 3 plus 2/3 2 over 9 of P times X, derivative with respect to P, 2 over 9X dx, setting P 0 and evaluating the integral, it is 214 over 3, then plus at section 2, integral of P times X minus 15, or P minus 15 times X. The derivative with respect to P is X dx, limit 0 to 2, setting P 0, evaluating the integral, it is negative 40. Then at section 3, we have integral 0 to 3 of quantity 353 over 6 minus 11p over 9 times x. Then plus p times 2 plus x minus 15 times quantity 2 plus x. Then the derivative with respect to p is 2 plus x minus 11x over 9. And setting p 0 prior to integration, evaluating the integral, it is 941 over 6. Then at section 4, we have integral 0 to 3 of quantity 353 over 6 minus 11p over 9 times 3 plus x, then plus p times 5 plus x minus 15 times 5 plus x minus 12x minus 7.5x squared minus 5 over 6 x cubed. And the derivative of this moment equation with respect to p is 5 plus x minus 11 times 3 plus x over 9 dx. And setting p 0 prior to integration, evaluating the integral, the value of the integral is 4345 over 12. So combining with 941 over 6, negative 40, and 214 over 3, the deflection at T is 550.25 over EI. So that's it for this video.